Alright, we are going to, there we go. We're going to find the increasing and decreasing intervals of 1 over x plus 1 squared. And textbook asks us to go ahead and graph it so that we can visualize it and see what our results are supposed to be. Alright, so here's what the function looks like. And it looks like the y values are increasing here, so I would say that's an increasing interval. And over here the y values are decreasing, so that's our decreasing interval. So just from the graph, if I had the graph, I could say it's increasing from negative infinity to negative 1, and then it looks like it is decreasing from negative 1 to infinity. So now let's see that we can find the same information using derivatives in calculus. Alright, so if I rewrote this with exponent rules, I could bring this stuff up to the numerator and just change the sign on the exponent. And I could use that information now to find the derivative. Apply the power rule, bring the power down, and then lower the power by 1. And since this is to the negative 3, let's go ahead and move it back to the denominator and make it a positive 3. Okay, so there is our derivative. So where the derivative equals 0 will give us our critical numbers. Okay, now this is where we're going to have to pause and hesitate a little bit here. If I was to multiply both sides by x plus 1 cubed, and I tried to put that over here, well, 0 times anything is going to be 0, so that would just make all of my x's go away. So I can't really seem to solve this algebraically. So maybe I think about it like a fraction. A fraction equals 0 when the numerator equals 0. But negative 2 doesn't ever equal 0. So this is going to have no critical numbers. There's nowhere where the derivative equals 0. Now, it could still be changing from increasing to decreasing if we have like an asymptote or some type of discontinuity. So where the denominator equals 0, I can see that would give me a vertical asymptote there. And so whether it's increasing or decreasing before that vertical asymptote, it's likely to be doing the opposite of increasing, decreasing on the other side. So those are the points I would like to test, or the point I should say. Might be changing directions at negative 1. So I need to pick something to the left and something to the right, and I can evaluate the derivative there, and I will know if the graph's going up or down. So I'm going to pick something easy like 0. And if I plug 0 into the derivative, like this, and ends up giving me negative 2. So the negative 2 is helpful to know exactly the slope of the tangent line when x is 0, but more importantly I want to see that the slope is negative on this side of the asymptote. Negative slope, negative derivative, graph must be going down. Now if I tried to plug in something over here, like maybe negative 2, oops, that's derivative not inverse, that's bad notation there. Okay, if I tried to plug in negative 2, it would look like this, and so this would be negative 1, but you square negative 1 you get positive 1, and that keeps it at negative 2. But I have a mistake here, and that's partly why we wanted to look at the graph, because I know that it's not actually going down and then down again. So here was my mistake. Hopefully you can learn from this. This was supposed to be x cubed, and I did that correctly here, but for whatever reason, I don't know, let's look at something else I guess. That was supposed to be cubed. So negative 1 squared might be 1, but negative 1 cubed is actually negative 1. So at an x value of -2, the derivative is positive, which means the graph is going up. So now, after a couple mistakes there, I've got my increasing and decreasing intervals that match up to the graph from the beginning. Okay, so it was increasing from -infinity to -1, and it was decreasing from -1 to infinity.